First, I want to explain what we in this project are interested in. So, a major focus point for us in this project is the bioenergy. So, the bioenergy is meant to have a major impact for the future climate change mitigation strategy. So that's why we are looking into this topic. And we want to answer the question, what is the potential for bioenergy in a future energy mix? And what is the role that bioenergy plays in future climate mitigation strategies? So, and the challenge is that bioenergy is affecting two different sectors, and maybe Jan can explain a little bit more what we are facing there.
Yeah, I mean, the nice thing or the nice opportunity we had within this project was that, so within the Hermitage project, was that we could couple different sectoral models. So what we did was, I mean, we have huge models which are covering specific sectors. In our case, we have a model which is covering the energy sector and a model which is covering the land use sector. And if it comes to questions like, for instance, bioenergy, you have this problem that these questions affect both sectors. So you have to couple the models to see the overall effect. And that's what we did here in this project for the first time. And it was quite interesting to see what happened. So what we did was, we had the energy model which were demanding bioenergy, and we had a land use model which was producing bioenergy and that was then giving information about the prices. And yeah, it was actually really interesting to see for the first time what happens if you put both together. So for instance, what we saw, and I think there you can say a bit more about it, was that if you compare to the runs we did before standalone, is that the bioenergy demand was much higher than before, and also the bioenergy production. So a lot more was going on there than we expected before.
There are quite a number of interesting results that we find out. So one of these results was that the more ambition the climate policy, which means the more or the fewer the increase of global mean temperature that the global society is willing to accept, the more bioenergy is used. So, and this is combined with the fact that the bioenergy is not used primarily because while it provides cheap energy, but because it helps to reduce emissions. So there is the possibility of making negative emissions out from bioenergy. So when the crops growing up, then CO2 is absorbed by the trees, by the plants, and this CO2 then can additionally be captured and sequestered underground. So this is a feature that is unique for the energy technologies that we have in our portfolio, and that's why bioenergy becomes so important.
And we also made a quite interesting decomposition analysis. They are trying to see how much of the bioenergy, or what are the reasons to demand the bioenergy and what are the shares. And if you look at the shares, I mean, it depends a bit on the scenario, but more or less what you could see in strong mitigation scenarios, around 80% of the demand came from emission reduction, and probably around 20% were just for the energy use. So this was something which was completely new to us and an interesting result. Besides that, I mean, another interesting effect you see there, we saw this huge demand for bioenergy, and the question is what happens with the land use sectors there. So, and what we found out was, I mean, everything has a positive and a negative side, and there we saw, I mean, if you have this huge demand from the energy sector, you also have strong implications for the food production. So what we saw was that there are sometimes in some scenarios really dramatic increases in food prices and also availability of agricultural land for production of other goods. So it's really nice to see all the effects, all the positive sides and all the negative sides together, and to get a complete view about what's going on.
And an additional fact is that the effects are different on a global and on a regional level. So there are some quite average effects on the global level. For instance, if you look to the land allocation that is served for production of bioenergy crops, in a scenario with a ambitious climate policy where you need much of this bioenergy, the land which is allocated to this bioenergy production is less than 1 or 2%. But if you look into different regions or in several regions, then this can increase to 10%. So that's quite a significant amount of land that is used for these bioenergy crops.
Mm-hmm. Yeah. So I think overall what we can say is, I think with this exercise we learned a lot, much more about the system and especially much more about bioenergy than we have learned before. And yeah, I think it was really a success from our side, or something where we had the feeling that we learned much more.